Welcome everyone to the course of Maintenance and Testing of Electrical Machines. I am Dr. Prashant Kumar Jena, Assistant Professor in the Department of Electrical and Electronics Engineering. Today in this session we will discuss about the preventive measures to control environmental pollution. So, imagine the world as a grand orchestra where every instrument plays a vital role in creating a harmonious melody. In this orchestra, electrical engineering is the conductor, ensuring that the symphony of modern life plays smoothly. But like any conductor, electrical engineering must be aware of the delicate balance between its power and environment. Just as a wrong note can disrupt a melody, unchecked environmental impacts can disturb the balance of nature. The goal is to maintain this harmony by controlling environmental pollution while continuing to advance technology. So, first we will see the environmental impact of power generation. So, within that we will first see fossil fuels. The ancient giants, the majority of the world's electricity is generated by using fossil fuels like coal, oil and natural gas. These sources of energy are the ancient giants of power generation and are very powerful, but also potentially destructive. When these giants awaken, they release a host of pollutants into atmosphere, including carbon dioxide, sulfur dioxide, nitrogen oxides and particulate matter. These emissions contribute to global warming, acid rain and respiratory illness, causing a long shadow over the environment. To control this pollution, a multifaceted approach is required. One strategy is carbon capture and storage, where CO2 emissions are captured at their source and stored underground. Another approach is the development of a cleaner combustion technologies such as fluidized bed combustion and integrated gasification combined cycle, which reduce the amount of pollutants released during the burning of fossil fuels. Think of these technologies as giant filters or shields that prevent the ancient giants' harmful breath from releasing the atmosphere. First we will see another one, renewable energy. Harnessing nature's bounty, renewable energy sources like wind, solar, hydroelectric and geothermal power are often seen as the gentle giants of power generation. These harness the natural forces of the earth to generate electricity with minimal environmental impact compared to the fossil fuels. However, even these gentle giants are not without their challenges. For example, solar power, while clean in operation, it requires the use of toxic materials such as cadmium and lead in the production of the solar panels. Wind turbines can disrupt local ecosystem and pose a threat to the birds and bats. Hydroelectric dams can alter river ecosystems, affecting the fish population and displacing communities. So, to minimize these impacts, engineers must carefully site renewable energy projects and design wildlife friendly technologies to explore alternative materials that are less harmful to the environment. So, the development of floating solar farms and offshore wind farms are examples of innovative solutions that aim to reduce the environmental footprint of renewable energy. These projects make use of space that is not traditionally used for energy generation, reducing land use conflicts and protecting the ecosystem. Next we will see nuclear power. The contained giant nuclear power is another significant source of electricity, which is often referred to as the contained giant because of its ability to generate large amount of energy from a small amount of fuel. While nuclear power does not produce greenhouse gas during its operation, it does present other environmental challenges, particularly in the form of radioactive waste. So, preventive measures for controlling pollution from nuclear power include the development of advanced reactor designs that produce less waste, the safe and secure storage of radioactive materials, and the exploration of new technologies such as thorium reactors, which produce less long lived radioactive waste than traditional uranium reactors. Additionally, decommissioning of old nuclear power plants must be done carefully to prevent the release of radioactive materials into the environment. Next, we will see transmission and distribution, which is the lifeblood of the grid. So, the environmental footprint of transmission lines are the arteries and veins of the electric grid, which carries electricity from power plants to our homes, business and industries. While essential, these lines can have significant environmental impacts, particularly in terms of habitat disruption and land use. For instance, the construction of transmission lines often requires the cleaning of forests, which leads to deforestation and fragmentation of the ecosystems. This can have a ripple effect, which disrupts wildlife habitats and migration patterns and contributes to the biodiversity loss. Moreover, the electromagnetic fields generated by the transmission line have a topic of concern, with studies examining their potential impact on human health as well as wildlife. To mitigate these effects, engineers are exploring the use of underground and underwater transmission lines, which have a smaller environmental footprint compared to the traditional overhead lines. Additionally, the use of high voltage direct current technology can reduce the amount of land required for the transmission line, as HVDC lines can carry more power over longer distances with less loss as compared to alternating current lines. So, another innovative approach is to use of green corridors. While transmission lines are integrated with wildlife corridors, allowing animals to move freely while minimizing the habitat disruption. These green corridors can also serve as carbon sinks, absorbing CO2 from the atmosphere and helping to mitigate and eliminate change, helping them to mitigate the climate change. Reducing the transmission losses. Transmission losses occur when some of the electricity generated at power plants is lost as heat as it travels through the transmission lines to the end user. These losses are like leaks in a water pipeline if not addressed. They can lead to significant waste and inefficiency. One way to reduce the transmission line is to improve the efficiency of the transmission system. This can be achieved through the use of superconducting materials, which have no electrical resistance and therefore do not lose energy as heat. Another approach is the development of smart grids, which use advanced sensors, communication networks and control systems to optimize the flow of electricity and reduce the losses. Smart grids also enable the integration of distributed energy resources such as rooftop solar panels and battery storage systems, which can reduce the need for long distance transmission and further decrease the losses. These systems are like local reservoirs that store water for use when needed, which reduces the reliance on distant sources and minimizing the risk of leak. Second one, addressing the visual and noise impact. Transmission lines and substations are often seen as eyesores in the landscape, and the noise generated by the transformers and the other electrical equipment can be a source of pollution, particularly in residential areas. While these impacts may not be immediately harmful as air or water pollution, they can affect the quality of life for people living near these installations. To address these concerns, engineers are developing designs that blend in with the surrounding environment, such as camouflaged transmission towers and underground substations. Noise pollutions can be mitigated by installing sound barriers and using quieter environment, much like how a well designed concert hall can enhance the acoustics while minimizing the outside noise. Next, we will see the pollution control in electrical equipment manufacturing. So, first the environmental cost of manufacturing. The manufacturing of electrical equipment from transformers and circuit breakers to consumer electronics, it involves the use of various raw materials including metals, plastics and chemicals. The extraction and processing of these materials can lead to significant environmental pollution, including habitat destruction, water contamination and greenhouse gas emissions. To reduce the environmental impact of manufacturing, companies are adopting green manufacturing practices, which aim to minimize the waste, reduce energy consumption and use environmentally friendly materials. For example, the use of recycled metals and plastics in the production of electrical equipment can reduce the need for virgin materials, thereby consuming natural resources and reducing the pollution. Another approach is the use of cleaner production of technologies such as water based paints and coatings, which reduce the release of volatile organic compounds into the atmosphere. These practices are akin to cooking a mud meal with organic ingredients and energy efficient appliances, which resulting in a product that is both healthier and more sustainable. Next, we will see the afterlife of electrical products, or we can say it the e-waste management. The electrical and electronic waste, otherwise known as e-waste, is one of the fastest growing waste products in the world. The discarded products from smartphones and laptops to industrial machinery often end up in landfills, where they can leach toxic substances like lead, mercury and cadmium into the soil and water. So, to address this issue, governments and industries are implementing strict e-waste management protocols, which include recycling, refurbishing and safe disposal of electrical products. The goal is to extend the life of these products, reduce the amount of waste generated and recover valuable materials from the for reuse. So, for example, take back programs where consumers can return their old electronics to the manufacturer for recycling are becoming increasingly common. These programs not only help to reduce e-waste, but also encourage manufacturers to design new products that are easier to deassemble and recycle. It is akin to giving old clothes a new life through recycling, rather than letting them pile up in the landfills. In addition, the development of circular economy models in the electrical industry is gaining traction. In a circular economy, products designed for durability, repairability and recyclability, ensuring that materials are kept in use for as long as possible. The approach is similar to a closed loop system where nothing is wasted and everything is reused. So, next we will see pollution from electrical operations and maintenance. So, first we go to oil spills and leaks. Transformers and other electrical equipment often use oil for cooling and insulation. If not properly managed, this oil can leak or spill, contaminating the soil as well as water bodies. So, these leaks are like hidden cracks in a dam. If not addressed, they can lead to significant environmental damage. Preventive measures include regular maintenance and inspection of the equipment, the use of secondary containment containment, the use of secondary containment in systems to capture any leaked oil and the adoption of environmental friendly alternatives such as biodegradable oils. These measures are key to regular checkups and maintenance of a vehicle, ensuring that it runs smoothly and it does not leak any harmful substances into the environment. So, in addition, the deployment of dry type transformers, which does not use oil, is gaining popularity as a way to eliminate the risk of oil spills altogether. These transformers use air or other flammable materials for cooling, making them a safer and more environmentally friendly option. Next, we will see managing chemical and material use in operations. Electrical engineering operations often involve the use of chemicals and materials that can be harmful to the environment if not properly managed. For example, the use of sulfur hexafluoride, or you can say SF6 in high voltage switchgear is a significant concern, as SF6 is a potent greenhouse gas with a global warming potential thousands of times greater than CO2. So, to mitigate the environmental impact of chemical use, engineers are exploring the alternatives to the SF6, such as vacuum switchgear and alternative gases with lower global warming potential. Additionally, the implementation of strict handling and disposal procedures for hazardous material is essential to prevent accidental releases and minimize environmental contamination. Another approach is the adoption of green chemistry principle, which aim to reduce or eliminate the use of hazardous substances in electrical engineering processes. Green chemistry is like cooking with natural non-toxic ingredients, ensuring that the final product is safe for both people as well as environment. Next, we will see the noise and electromagnetic pollution. So, beyond the obvious, noise pollution from electrical equipment such as transformers, generators and substations can be a significant issue, particularly in urban areas. Prolonged exposure to high levels of noise can lead to stress, sleep disturbance and other health issues, which is much like to the constant drone of traffic in a busy city. To reduce the noise pollution, engineers are deploying or developing quieter equipment and implementing noise barriers such as soundproof enclosures and vibration damping materials. These measures are similar to installing double glazed windows in a house to reduce outside noise, which creates a more peaceful and comfortable environment. In addition to noise, electromagnetic pollution, also known as electromagnetic interference or EMI, this is a concern in electrical engineering. The EMI can disrupt the operation of electronic devices, which leads to malfunction and potential safety hazards. To control EMI, engineers use sealing, grounding and filtering techniques, which are akin to use insulation to prevent heat loss in a building, which ensure that the system operates efficiently and safely. Next, we will see adherence to industrial and environmental guidelines. So, within that, first we will see the international standards. The framework for sustainability for various international standards and guidelines play a crucial role in controlling the environmental pollution in our electrical engineering. These standards provide a framework for companies to develop and implement effective environmental management systems, which ensures that their operations are sustainable and environmental is feasible. One of the most widely recognized standards is our ISO 14001, which provides a framework for environmental management systems. ISO 14001 helps organizations to identify and manage their environmental impacts, set measurable goals for improvement, and ensure compliance with environmental regulations. It is akin to a set of rules for a game, ensuring that all players, that is industries, engineers and consumers, work together to protect the environment. Another important standard is the restriction of hazardous substances, that is RoHS, which RoHS, this directive limits the use of specific hazardous materials in our electrical and electronic products. The RoHS is particularly important in controlling the pollution associated with the manufacturing and disposal of electronic products, which ensures that harmful substances do not end up in the environment. Next, we will see environmental impact assessment, that is known as EIA, which is the blueprint for responsible development. Okay. The blueprint for responsible development before any major electrical engineering product that is required to proceed. It typically undergoes an environmental impact assessment, that is EIA. An EIA is a detailed study that assesses the potential environmental impacts of a project and identifies measures to mitigate these impacts. It is like drawing up blueprints before constructing a building, ensuring that all potential risks are considered and addressed. EIAs are required by law in many countries for projects that are likely to have significant environmental impacts, such as the construction of power plants, transmission line and substations. The EIA process involves public consultation, allowing stakeholders to voice their concern and contribute to the decision making process. The outcome of an EIA can influence the design, location and operation of a project, ensuring that environmental considerations are integrated into the every stage of development. For example, an EIA might recommend the use of renewable energy sources, the relocation of a project to avoid sensitive habitats, or implementation of additional pollution control measures. Next, we will see sustainable design and green building certifications. Sustainable design is an approach that seeks to minimize the environmental impact of buildings and infrastructure throughout their life cycle, that is from construction to operation to eventual demolition. In electrical engineering, sustainable design involves the use of energy efficient systems, renewable energy sources and environmental friendly materials. Green building certifications such as LEED, Leadership in Energy and Environmental Design, and BREEAM, which is Building Research Establishment Environmental Assessment Method. They provide a framework for evaluating and certifying the sustainability of buildings and infrastructure. These certifications consider factors such as energy efficiency, water use, indoor environment quality and the materials used in construction. For example, a LEED certified building might use energy efficient lighting and HVAC systems, which incorporate solar panels and green roofs and use recycled and locally sourced materials. These measures reduce the building's environmental footprint and contribute to overall sustainability, much like a chef who sources local and organic ingredients to create a meal that is both delicious and environmental friendly. Next, we will see the future trends in pollution control. First is electrification and decarbonization. The path to a cleaner future electrification refers to the process of replacing the technologies that use fossil fuels with those that use electricity, particularly in sectors such as transportation, heating and industrial processes. Decarbonization involves reducing the carbon intensity of electricity generation, primarily by increasing the use of renewable energy sources. The electrification and decarbonization of the energy system are key strategies for controlling environmental pollution in the future. By shifting to electricity generated from renewable sources, we can significantly reduce the greenhouse gas emissions and other pollutants associated with the fossil fuel use. The transition is akin to switching from coal to cleaner burning natural gas, but on a much larger and more impactful scale. For example, the widespread adoption of electric vehicles can reduce air pollution and greenhouse gas emissions from the transportation sector. Similarly, the electrification of heating systems, such as through the use of heat pumps, it can reduce the reliance on fossil fuels for residential and commercial heating. To support electrification and decarbonization, the electrical grid must be upgraded to accommodate the increased demand for electricity and the integration of variable renewable energy sources. This method includes the development of energy storage systems such as batteries and pumped hydro storage, which can store excess electricity generated by renewables for use when demand is high. Next, we will see circular economy. So, closing the loop, which is circular economy, is otherwise known as the closing the loop. So, the circular economy is a concept that seeks to create a closed loop system where products are designed for reuse, repair and recycling rather than being discarded at the end of their life. In a circular economy, materials are kept in use for as long as possible, extracting the maximum value before recovery and regeneration. So, in electrical engineering, the circular economy involves designing products that are durable, modular and easy to repair, as well as developing system for the collection, recycle and repurposing of electrical and electronics waste. This approach is akin to a gardener who composts organic waste to enrich the soil, which ensure that nothing is wasted and everything is contributing to the health of the ecosystem. So, for example, companies are developing modular electronics that can be easily upgraded or repaired, reducing the need for consumers to buy new products. Similarly, the development of a take back and recycling programs helps to ensure that valuable materials such as rare earth metals are recovered and reused rather than being lost in landfills. So, at the end we will see the conclusion what we have studied till now. So, to conclude it, we can say that weaving a sustainable future, as we navigate the challenges of the 21st century, the role of electrical engineering in controlling environmental pollution becomes increasingly important by adopting preventive measures such as green manufacturing practices, sustainable design, adherence to international standards and the development of innovative technologies. So, we can reduce the environmental impact of our industry and contribute to a more sustainable future. The future of electrical engineering lies in our ability to innovate and implement practices that minimize our environmental footprint while continuing to advance technology. As engineers, we have the power to shape the world not just through the electricity that lights up our cities, but through the sustainable practices that ensure a brighter future for generations to come. It is time to weave a web that supports both human progress and the natural world, which is creating a legacy of sustainability in the field of electrical engineering. By harmonizing the needs of the society with the needs of the environment, we can create a symphony that resonates with the values of sustainability, innovation and responsibility. As we concluded our exploration of preventive measures to control environmental pollution in electrical engineering, it is clear that our role as engineers extends far beyond simply generating and distributing the electricity. We are custodians of both technology and the environment, tasked with the balancing of demands of modern society with the need to protect our planet for future generations. By embracing sustainable practices, innovative technologies and stringent guidelines, so we can reduce the environmental impact of our industry and pave the way for a greener and more sustainable future. But our journey does not end here. While safeguarding the environment is crucial, so too is ensuring the reliability and safety of the electrical systems that we design and maintain. This brings us to the next critical aspect of our profession, that is troubleshooting of electrical equipment. So, in the upcoming discussion, we will delve into the methods and techniques used to diagnose and resolve issues in electrical systems. Effective troubleshooting is the key to preventing equipment failure while reducing the downtime and maintaining the integrity of our electrical infrastructure. So, join us as we transition from environmental stewardship to the art and science of troubleshooting, where we will explore how to keep our systems running smoothly and efficiently in an ever evolving technological landscape. Thank you for attending the lecture. Next class we will see. Thank you.